All right, let's talk about the derivatives of trigonometric functions. So there are six basic trigonometric functions: the sine, the cosine, tangent, cosecant, secant, and cotangent, which these relationships are listed here. So essentially everything can be written in terms of sine and cosine, which when you're doing any types of proofs, which you may have done in pre-calculus or college algebra, but most likely pre-calculus at trig, then these are some of the identities. The most popular is sine squared plus cosine squared is equal to 1. Now, these trig functions are functions that need some sort of variable, independent variable inside, hence the theta. Okay, sometimes that's x, sometimes that's y, but you can't write the sin all by itself without having a variable inside the function. So if this is a little rusty for you, you may want to pull up some videos on trig functions and understanding their relationships and their graphs. When we're talking about the derivatives, remember that they are all valid only when x is measured in radians. So typically when you're in a calculus course, the majority of your trig calculations will be done in radians, if not all. So here the derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of tangent is secant squared. Cosecant derivative is negative secant x times cotangent x. The derivative of secant is secant x tangent x. The derivative of cotangent is negative secant squared x. Now, essentially, these, for the most part, just get memorized. There is no easy way to remember them. So I suggest that you make a little table for when you need to use them on any exams. Let's now move over and try a couple examples using some of the rules we've already learned, like the product rule and the quotient rule. So I'm going to now head over to the whiteboard to do some examples with you. Okay, so our first example, we will conduct the derivative of the function f of x is equal to x squared sine of x. So we see that this is a product. There are two functions. Our first function is x squared, while our second function is sine of x. So remember when we have to induce the product rule, which I know this is a product rule because again, there's two functions being multiplied. I'm going to label my first function x squared and my second function sine of x. And then I'm going to find their corresponding derivatives before plugging them into the product formula. So the derivative of x squared is 2x, and the derivative of the second function sine x is cosine x. And then we do the product rule, which states that if you are multiplying two functions together and you'd like to take the derivative, you are going to pair the derivative of one with the original of the other, plus, and then you switch. It doesn't matter the order in which you write the derivative with the original function, whether the first function gets the derivative first or the second, because it's all multiplication and addition, which is all commutative. So let's fill this in. The derivative of f of x is equal to the derivative of the first times the original second plus the derivative of the second times the original first. I'm going to write it in front so that I'm not confused and don't think that it's also inside the cosine. And that's it. That's the derivative of this example. Let's try another one. Let's try one and recall the quotient rule. So let's say that f of x is equal to 1 plus sine of x divided by x plus cosine of x. Now, when I take a look at this, the overall picture, the biggest rule is that division, which is where I get the quotient rule. So recall that the quotient rule, if we are dividing the top function divided by some bottom function and would like to take the derivative, the order does matter this time because there is a subtraction in the formula. So we have the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. So because there's a subtraction in the numerator, remember that the derivative of the top needs to come first. So again, I'm going to split this up. My top function is 1 plus sine of x, and my bottom function is x plus cosine of x. The derivative of my top, well, the derivative of 1 is just 0, and the derivative of sine is cosine. The derivative of my bottom, the derivative of x is 1, and the derivative of cosine is negative sine. So I'm going to change that plus to a negative. Let's put it all together to find the derivative of f of x. So we have the derivative of the top, which is cosine x, times the original bottom, x plus cosine x, minus the derivative of the bottom, 1 minus sine of x, times the original top, 1 plus sine of x, all over the bottom squared. Now, I'm not requiring you guys simplify these crazy quotient rules, as I mentioned when we learned the quotient rule. So keeping it just like this is perfectly fine. And this is basically what we do with trig functions. We just have that chart in front of us and apply their derivatives as needed.